So today is lesson 7. So we're going to do some more work around authentication and authorization today. We're going to have a look at assignment 2, which is going to be due. I've actually pushed back the due date for assignment 2 by a week. We're going to talk briefly about SSL certificates and why they're really important in web development and web design. And then we're going to integrate social authentication into our clothing store. So we're kind of do this in 2 parts. The Google authentication piece we're going to work on together collaboratively. And then I'm going to put you into breakout groups in WebEx and have you work on integrating Microsoft login, which is similar, a little bit different, but similar to Google login. So we'll have you integrate that. We should be able to get that running by the end of class today. And that's going to be a graded activity. So it's going to be, as long as you're participating in the activity today, I'll record a mark for you. If you are doing this lesson asynchronously, you're doing it based on the YouTube videos at home, then you'll need to upload your code to GitHub and email it to me so that I can review it in order for you to get those marks. So I want to have a look at assignment 2. I've marked everybody's assignment 1. The submissions were really good. I got lots of good projects. Kevin, I'm just going to mute you there. So I got lots of good projects. A few of them just needed some polish, especially in the user interface. But I was happy to see that most people were able to get the basic MVC performing CRUD operations and get that working. So for assignment 2, you're going to build on what you've already done for assignment 1. So I'm going to go through the requirements. Now I've updated the syllabus. The original date in the syllabus, the due date for assignment 2 part 1, was going to be November the 10th, which was right after reading week. So I've decided to push it out another week, so that way you don't have to do this over reading week. If you don't want to, I'm giving you an extra week. The assignment part 1 is not that long. It really won't take more than a couple of hours, but you have 20 days to do it, which is lots of time. So I would expect that no one should have any issue getting this handed in on time. So the assignment's broken down into 3 parts. It's 25% total. So part 1 is 10%, part 2 is 10%, and part 3 is 5%. And you're basically just going to submit the same things on Blackboard that you've already submitted for assignment 1. Just give me the Git repo and the Azure link. And you can give me the same links you've already given me. You don't have to create a new repository. You don't need a new Azure website. We're going to just keep adding on to what you've already done. As with before, you do have to do all your own work on the assignment. There is no sharing. I get work that looks a bit strange, so I did get a few submissions that looked very similar. So I had some meetings with students for code reviews, and we walked through those, and I wanted to make sure that the students could verify that they understood the code that was in there, and they had to demonstrate their learning. So for part 1, what we're going to implement is authentication into your existing assignment 1 project. And we're going to implement both local authentication like we did last week, as well as Google authentication, which we're going to do today. You are not required to implement authorization. So in your assignment, you don't have to have different roles and permissions. You can if you want to, but it is not required. We're really just focused on basic authentication. Then part 2 revolves around unit testing. We'll look at that later. And then part 3, we're going to build a REST API using Visual Studio. But for now, we're really only concerned with part 1. It's out of 15. So what do you have to do in your assignment? You're going to take your assignment 1 project. First thing you're going to do is make the change we made last week. You're going to disable the account confirmation email in your startup file. So if we register a new account, it's not going to try to send a confirmation email. Second thing you're going to do, pretty simple. I'd like you to create an account for me with this set of credentials, please. So you'll click on your register link. You'll enter this username and this password. And this is just to help me that I can give you your grades back faster. I've got 3 sections of this class. if I have to create an account for myself in about 85 different projects, that's just going to be time consuming. So I'm going to ask you to please create an account for me and use this credential. And then that way I can just log into everybody's site using the same login. You're then going to modify assignment 1 so that all the views for adding, editing, and deleting are private. So I won't be able to access your create, your edit, and delete views unless I am logged into your site. And on the index view, I should be able to see your list of data, but I should not see the links to go to create, edit, and delete. So basically your index views become read-only for anonymous users. And then only when someone is logged in will they see the add, edit, and delete methods and links. You're also going to enable Google Authentication, which we are going to do today. So you're going to have to follow the process that we're doing in class today. You're going to need a NuGet package. So there's there's a library from Microsoft that we're going to need to add to our project. We're going to need to create API keys in the Google Developer Console and then include those in our project and add some configuration in Visual Studio so our project can use Google Sign-In. And you'll have a couple of options for where to store the keys. Your easy place is in your Appsettings Json file. The recommended way to store it is actually in the Windows Secret Manager and the Azure configuration. So we're going to start today with the quick and dirty storage of the keys. That's in our appsettings.json. And then I'm also going to show you how you can use the Secret Manager and Azure configuration. You can use either method in your project, but using the Secret and Configuration Manager is actually the recommended method. And you'll commit to GitHub regularly. So if you get full marks, I want to see you've committed at least 4 times over at least 2 calendar days. Make sure your README file is up to date and that your application is published to Azure. Okay. So you've got 20 days to do this. All in all, you have to write very, very little code to get this to work. Like probably about 10, 15 lines of code is all you will need. And the rest is just setup and configuration. So basically the things you got to do for assignment 2 part 1 are the things you did in class last week, plus the things we're going to do in class today. Are there any questions from anybody about the requirements for assignment 2?
I have one question for part 5 of part 1. When it says use Git Ignore so the packages folder does not include in your online repository, what exactly do you mean by that?
Okay. Let's go and look at our project. This should be done automatically for you, so you really shouldn't have to do anything, but I will show you. Good question, Lindsay.
Thank you.
So here's our in-class project. So what you'll notice when in Visual Studio, when you add a project to source control, after you if you've created a project, you would already have this Git Ignore file. Mm-hmm. This gets generated automatically by Visual Studio when you add your project to source control. So what it does is it excludes all the dependencies that our project needs. So when here's a project for my different class. So I've got these dependencies. What have we got? Under packages. So if I go and actually look at the folder in So this lists all of our dependent files, all the libraries we're using.
Okay.
So the Git Ignore excludes them. So all the dependencies don't have to get copied up to GitHub. So you don't really have to worry about that requirement. This is something we used to have to do manually. It's now basically done for us.
Okay, perfect.
So
Thank you.
don't really need to worry too much about that item.
And why are you asking for the Git Ignore?
Well, it should be there already, Kevin. So you shouldn't have to do anything. I think everyone probably has the Git Ignore already. Visual Studio creates it for us now.
So what's important about it, like file size or makes it quicker to pull or something?
I'm sorry, I'm not sure I quite understand your question.
Just trying to think of a better way to word it.
No problem.
To word this. I'm still kind of confused on the importance of Git Ignore.
Okay, so what Git Ignore does when we build projects, a lot of our projects have dependency files, right?
Yeah.
Third-party libraries. So here's our project we're building together. So inside the bin folder, we have all these libraries for Microsoft. And these libraries, they can get really large. So what the Git Ignore file does is it says when we push those files to GitHub, it's not going to include a copy of all of the dependent libraries. We don't need to copy these because these aren't our code files. These are just support libraries that our project is using. So
all it does is just ignores the stuff you already have, right?
yeah, it ignores all the references our project is making. And if we look, let me look here. Bear with me for a second. So we don't need to include them because in our project file itself, if we open it in a text editor, it shows the dependencies we need. So what Git Ignore does is says when we push to Git, it doesn't copy these dependencies from our computer so that our upload is smaller. So then you may think, okay, but when we put the website on Azure, if these packages aren't copied, isn't Azure going to miss them? And then we're missing all our dependencies. No, because our project lists the dependencies it needs, and Azure will automatically include them for us. So the Git Ignore is designed so that we're not just copying all these third-party libraries that already exist on the server. We can ignore them on GitHub, and we just pull them from our server instead.
Oh, that's pretty neat.
So it's basically just about, shrinking the footprint of our Git repository and making those uploads quicker.
All right.
So we used to have to do some of this work manually, and you'll see this. Are you guys taking JavaScript frameworks this semester or next semester?
This semester.
Okay, so you'll see that. You probably see this if you work with GitHub within Node.js, because with Node, you have many, many dependencies in your Node modules folder. So like megs and megs worth of Node modules. So that folder gets ignored in the Node Git Ignore. So all those dependencies don't get included in your Git repositories to make them lighter. So in our case, Visual Studio takes care of this for us, so we don't really need to worry about this item. Does anybody else have any questions about your assignment? Now, there are still a few assignment ones that I never got. The submission date is long past for those. Those were due 8 days ago. If you haven't done assignment 1, you're going to need to do the work on it in order to do assignment 2. You're not going to get graded on assignment 1 at this point, but you're still going to need to build the project in order to do assignment 2. All right, so we will move on to this week's lesson. So here's what I want you to do next. We're going to quick brainstorm. Before we get into looking at Google Authentication, I want to spend just a little bit of time talking about SSL. So there's an item here for you in the week 7 folder. It says, what do you know about SSL? And there's 2 links. There's a link to the Padlet login screen. So I want you to log in there, choose Microsoft, and you can log in with your school credentials. And then once you're logged in, I want you to visit this little Padlet whiteboard that I've created. And in here, you can add the plus sign and add anything you know about SSL. Also be sure somebody's added to this already. Maybe add your name to your sticky note. So click plus, generates a sticky note. Kevin, the URL is it's in the week 7 folder. So link 1 is the login screen. Link 2 will take you to, yep, no problem. Yeah, that's a good question. Do we need to pay for them? How do we get a free one? What's important? Good questions. We'll look at some of these. Remember to put your name on your sticky note as well. Kevin, you just click the plus sign down at the bottom, and it'll add a note for you. Yeah, you should click the plus sign, and it should open a sticky note for you. No problem. We all have those days. I totally hear you. I know it's been a long time, so, and I know you guys have exams. I totally respect that, Kevin. Okay, Dan, that's good. Not knowing anything is fine. That's why we're going to talk about it. Okay, so yeah, Lindsay, you're right. So it is a type of protocol. Okay, so Utsav, that's a good point. Right, it's around being used for sending information securely. True. Yep, so certificate, that's true. Who's writing this note? A file hash. Make sure you put your name in there too, because that's important what you're saying. It's right. Yeah, you got it, Jeffrey. So that's an important thing, that the certificate is issued by a recognized certificate issuer. This is why when we run our local site for the first time, we build a new project and we choose HTTPS and Visual Studio and we run it, we get an error in the browser or a warning saying the certificate authority is not recognized. And that's because Visual Studio is creating its own certificate. It's not coming from a recognized certificate issuer. Yeah, you're right, Sierra. That's a good point. So it doesn't affect the speed. Right. So it's around encryption. Okay. So you guys are on the right track. Mikkel, in the week 7 folder. So you log into Padlet with your account, and then you click the second link in this item. What do you know about SSL? All right, that's a really good description. Somebody added at the top. Small data files that cryptographically establish an encrypted link between a web browser and a server. Yes, Kevin, and I'll explain why. There are a few reasons why. So normally, HTTP... Oh, you didn't have to log in? Okay, that's fine. The nice thing is if you log in, it will automatically put your name in. I think it automatically puts your name in there. Yep, that's right, Barack. So HTTP normally transmits data in plain text. So when a user fills out a form in their browser and clicks submit, it sends that info to the web server, or maybe that includes a password or includes a credit card number, or we write a query against the database fetches our data and then sends it back in a view. All of that traffic occurs in plain text over HTTP. So the idea of an SSL certificate is, as many of you mentioned, it encrypts that traffic. So if an attacker happens to intercept communication going between a browser and a web server, it's not transmitted in plain text, it's encrypted, which makes it harder to see the content of that traffic. Okay. So we'll look at what this, I'll just wait for Mikkel to finish his note. Okay, so it's new. So every site we build should have an SSL certificate, even if it's just like a static site and there's nothing sensitive that needs security. And there's a couple reasons why. I put a link up here that you can read on your own time. So two important reasons. The first important reason is, and this sort of describes, so it uses TLS. It creates a valid digital certificate. We'll look at what one of these looks like. So we can actually see here, most sites you visit nowadays, you're going to see a lock here. So what does that lock indicate? It tells us our site's running under SSL. We can see here, if I take out the S, it redirects me back. So all requests are forced to use the secure version. And we can actually look at the SSL certificate. It says we have a secure connection. This is the certificate issuer, TrustWave, issued the certificate. And we can actually see details about the certificate. When does it expire? And it even shows us the encryption algorithm. So it's using SHA-256 with TLS 1.3. And we can even view the SSL certificate here that verifies the authenticity of the domain. It doesn't guarantee the website is safe, but we can have some confidence that the SSL certificate is registered to the proper domain. And it's by a valid certificate authority using this encryption algorithm. So since actually 2015, and that's what marks our sites as secure in our browsers. Since 2015, Google also factors SSL in their search engine rankings. So if you have two similar sites, one uses SSL and one does not, the one using SSL is going to rank higher in search results. So even if your site, again, even if it's static, there's nothing sensitive on there, if we want people to find it, Google's going to find it more easily if it's got an SSL certificate. The other thing is we see this secure here, for example, in Chrome, but Chrome also marks, so here's a website that doesn't use an SSL certificate. The site loads, but you'll notice here Chrome marks it as not secure. It doesn't mean the site is dangerous or you're going to get a virus, but this is going to scare a lot of users away when they're used to seeing sites that are marked as secure. So almost any site you go to nowadays is going to run under SSL. Like if we look, Blackboard's under SSL. Here I am on Elegant Themes. Padlet's under SSL. I'll just go load a couple other sites. Where do I go commonly? Usually I look at the Globe and Mail in the morning, right? SSL. Where else do I go? I like to read the Guardian newspaper. It's just become standard practice by this point. Right? So every site we build should have it. even our local app, so here's one of my apps, right? When we created our store, this is from my Monday class, we checked off the box for enable SSL. So all our requests are using HTTPS. I'm going to come to the great question. I'm going to come to that in just a second. Yes and no is the answer. So you'll notice here, we're running under SSL, but we get a partial lock with a warning, right? The very first time we created our project and ran it, our browser didn't show us the site. It gave us an SSL warning. So you can see this little warning here. It says, I'm not secure. And the reason is because our certificate was verified by localhost. We didn't buy the certificate at a VeriSign, a TrustWave, or one of these other companies that are recognized certificate authorities. This is a Visual Studio generated SSL. So there is SSL, but our browser doesn't really recognize it. So that's why we get this warning. It was issued by localhost. It is using SHA-256 encryption, but the browsers don't recognize it. So that's why we get this kind of partial, we had to add this exception. Okay, so you asked good questions about like cost. So I think Mike, you mentioned it. Jeffrey, you've mentioned as well. There's a couple of options for certificates. Many web hosts now support free SSL certificates with this service called Let's Encrypt. So these are 90-day certificates that will automatically renew. And many service providers support them. So you don't have to pay for these. So for example, here's a company I host some domains with. If I want SSL on any one of my domains, I can just go in here. And all I would have to do is just enable Let's Encrypt. So this web hosting company, they support it, so I get free SSL certificates here. Not all hosts do. So for example, a host like these guys that are big, see their ads all the time. So Godaddy doesn't support Let's Encrypt. If you're hosting your site on Godaddy and you want an SSL certificate, which you do, they start for the low price of $85 a year on Godaddy. You have no choice if you want SSL on Godaddy. You can only buy their certificates that start at $85 a year. Now the SSL certificate prices have come down. The first time I bought one, probably 15 years ago, maybe closer to 20 years ago, the cheapest one I could find was $300 a year. Yes, actually I do. I've hosted with these guys, LFC Hosting, for many, many years. They're based in Saskatchewan. They're not a huge company, so when you call them, you actually get to talk to the same people. I've known the server administrators there for many years. They're great, and you can get a hosting package for them. I think it's starting at $9.95 US per month, and you can host .NET and you can host PHP MySQL with them. So they support Let's Encrypt. The other place that I go to get cheap SSL certificates, if I've got a client who's hosting on a server that doesn't support Let's Encrypt, is Namecheap. So Namecheap offers a whole suite of certificates. I can actually put these links up on Blackboard for you guys. So you can buy an SSL certificate for as low as $5 a year. Now, if you buy one from a third-party provider like Namecheap, you have to buy the certificate here, but then you have to do some back and forth between the certificate issuer and the hosting company. In order to generate the certificate, you have to ask your hosting company to create a certificate request. So this is an encryption code that gets embedded into the certificate you buy. And once you've finished buying them, you have to download your certificate. Looks something like this. So here was one I downloaded from last year. Yeah, so there is some back and forth, right? I have to get this certificate, I've got to upload it, and then ask the server administrator to install it. So this is what I used to have to do here with LFC Hosting until they added Let's Encrypt support. Now, I would go to Namecheap. These guys would sell me a certificate, but they wanted $75 US per year. Now, I'd pass that cost on to my client, but I would feel bad asking them to spend $75 US on a certificate, knowing that with a little back and forth, I could go to Namecheap and get them one for $10. So Let's Encrypt is definitely the easiest option. SSL with Godaddy is simple. You basically just buy it and they take care of the installation and configuration, but it's a lot of money. Yes, so if you look, so the cheapest ones are single domain only. So here, this includes, for example, 3 domains. You've got wildcard. So for example, like we're using with azurewebsites.net, one certificate covers all the subdomains of that. You also have different levels of warranty. So their most expensive one, for example, gives you up to a $1 million warranty. So if there's issues with the encryption, the warranty is higher on the more expensive ones. This one also displays a green bar displaying your company name in the URL that ensures users. So there are some different levels. For most basic sites, an inexpensive one or Let's Encrypt is sufficient. It doesn't have different encryption. No, if we actually compare. So let's compare like the cheapest one with the most expensive one. We'll compare a couple of them. So one website versus 100. This does additional validation. It includes all your subdomains. The warranty here is $10,000. Here it's $1 million. But it's still the same level of encryption. In effect, yes, Jeffrey, you're buying insurance, in effect. Okay. So any website you publish from now on should be using SSL. Like I said, even if it's just HTML and CSS, and you're just going to use a free Let's Encrypt certificate. We want our sites marked as secure in the browser, and we want them to be search engine friendly. Okay, and this is going to be if you're have a project where you're publishing a website, this is going to be your responsibility. Your clients may not even know about it. If you're going to build a site for a friend, for a client, you have to have SSL on it. Okay, so let me close out of these things. Okay, so hopefully for those of you who said SSL is new, you've got a little bit of understanding around it, and know that this will be something that we'll need to do with any time we publish a website or web application. Okay, so I want to move into the next part of our lesson today, which is integrating Google Sign-In. I'm going to show you how we did it in our Monday class and what it looks like so you get an idea of where we're going. So on my login screen, before we had some text here that said, there are no external providers configured. We've configured Google. So I get a Google button here. When I click it, it brings me up to a Google login box where it's got a name of my application. I'm already signed into a Google account, so I'll just click on it. It authenticates me through Google, and I'm signed in to the store. I can't see the categories and products, but I am an authenticated user. So this is what we want to do today in our clothing store. We're going to do this one together, and then you guys in groups and WebEx breakout rooms are going to work on implementing the Microsoft login afterwards. So let's have a look at the process that we've got to follow in order to do this. So what we're going to do, it's basically coming out of this tutorial from Microsoft, and we'll need this link later for the next part when you're working on the Microsoft login, and this link is on Blackboard already. So we're going to have to set up for Google, we're going to have to set up a set of API credentials in the Google Developer Console. So we're going to go there. I'm just going to kind of walk you through the process of what we're going to do, and then we will go through it together step by step. So we're going to go to the Developer Console, and these slides are on Blackboard already for you, so you have all these screenshots as a reference, because you'll need them to implement in assignment 2. So we're going to go to the Developer Console, we're going to create a new project, and then once we've created a project, we're going to configure the consent screen. So the consent screen, what this means, the consent screen is this pop-up window. And all we really need to do to configure it is put in a name of our website. We then need to choose what type of authentication we're allowing. Are we allowing internal, meaning users within an intranet that have Google accounts, or are we opening it, making it public for any Google user? So we're going to choose external. We're going to let anybody with any valid Google credential log into our store. On the consent screen, we're just going to add an application name. We're going to leave the rest of the form blank and submit it. We then need to create an OAuth client. So we're going to click on Create Credentials, and we're going to choose OAuth Client. And we're going to form that looks kind of like this, where we're going to have to add in 3 values. We're going to choose web application, because we'll have options. What kind of app are we building? Web, Android, iOS, something else. So we're going to pick web. We're going to give it a name. And then we have to add in 2 redirect URIs. And you can, maybe a little hard to see on my screen, what do you suppose those redirect URIs mean? Why are we going to need to provide those to Google? A universal resource indicator. So it's like a URL. A URL is an example of a URI. Right, Mike, that's right. Once somebody successfully signs in to Google, right? Once I sign in here, Google needs to know, where do we send the user back to? Because they're not going to stay on Google's site. They've got to come back to our site. So we want this Google sign-in to work both locally as well as if we publish the application to Azure. So I'm going to include both. I've got my local domain and my Azure domain. And at the end of the domain, I add /signin-Google. Because the library we're going to use for doing Google sign-in, that's the page that will receive the users when they come back from Google. So we're going to add both of those in the Google console. This is then going to generate a set of API keys. So we've got a client ID, which is like the identifier of our app on Google. And then we've got a client secret, which is basically like the password. So if our app got compromised, we can reset the client secret. So Google will generate these for us. And then we're going to need to include these values in our web application. So our web application can access the Google project. So there's 2 ways we can do this. The quick and dirty way is using appsettings.json. We can set up an area, a Google section of appsettings.json, and we can add the client ID and add the client secret there. This will work both on our local machine as well as on Azure. They're not encrypted though, so it's not really the recommended place to be saving this data. We're going to do it this way first, and then after, if we've got time, I'll show you the recommended place, which is using it's now called the secret store, as well as the Azure configuration section. So this way they're stored separately and they're encrypted. So using the secret store, we run some commands in the package manager console. So it would look something like this. .NET user secrets, and we set up our Google client ID and client secret. To do this in the Azure portal, Azure has a configuration section we haven't used before. And you'll want to do this for your assignment 2, part 1. So we go into configuration and we click a new application setting. And then we create 2 settings. We put in our client ID as the name and our value from the Google console. And then we repeat this with the client secret. So this will override anything we put in appsettings.json. This takes precedence. It also allows us to have different variables for our local version and our live version. We then need to install a NuGet package. We need to install the Microsoft.ASP.NET Core.Authentication.Google library. This has all of the code that we need for interacting with Google's sign-in service. And then in our startup file, we need to enable Google Authentication by calling the add Google method and getting our app to read the client ID and secret. So this code can read them either from appsettings.json or from our secret key store. The code will work with both. So we've got to add these 8 lines of code into our startup file. Once we've done all that, if we refresh our login page, we're going to get a Google button automatically showing up. We don't have to put it there. The library we're using will generate this. And we click it, and after we authenticate with Google, we'll get redirected back to our site, and we'll get a page that looks like this. Say we've successfully authenticated with Google, and it will take the email address from the Google account, put it into the text box, and allow us to register our user account. Lastly, we'll come to your question in a minute, Jeffrey. Any users that are registering through an external service, they don't actually go to the ASP.NET users table. So last week when we created customer and admin accounts, those are in our ASP.NET users. We have a separate table called ASP.NET user logins. So we'll have a new user ID, and it'll tell us the provider name as well as a key that we get from Google that identifies the user in the Google ecosystem. So Jeffrey, can you maybe clarify your question a bit?
Can you hear me?
Yep.
Okay. I was just asking that because just as a developer, we have to always continually go and find, okay, I want to use this, so how do I use it? I have to go find the code to use that, So
Right. Okay. Good
to
question.
know where.
Yep. So that code comes, and I'll put this link in the chat because we're going to need it. So everybody may want to open a browser tab. So this is the official docs from Microsoft on implementing external login in .NET Core 3.1. So this gives an overview right from, setting up a new project. We don't have to do all of this part. So there's links at the top for different providers. So we're going to do Google together, and then you guys are going to do Microsoft as a group activity. So in the Google tutorial, it goes through the steps. So your code is right here. So this is straight from the official docs from Microsoft. This is how we add the Google service at the time of application startup, with a description here of exactly what each piece of it is doing. Does that help?
Yep.
Okay. So we're going to basically go through this together. And then in groups, you guys will follow the Microsoft sample, which is similar, but of the few differences with how you would set up the application in the Microsoft portal. Okay, so let's open up our project and just get it running. And close up most of my files here. I'm really just going to keep startup and appsettings.json open. Those are the only files we're really going to modify. So here's our shop. And when we go to log in or to register, right, we get this message. There are no external services configured. And then it links, I think, to the same tutorial. Yeah, it gives us the link to the same tutorial about how do we enable a third-party login service. So that's kind of useful that Microsoft takes us right there how to do it. So when we enable Google, the Google button is going to replace this text on both the register and the login. So a user doesn't have to register and log in if they're using Google or Microsoft. They just do either one. If their account doesn't exist, it registers them. If their account does exist, it'll just log them in. All that happens automatically under the hood. Okay, it is 10 to 12. So just make sure you've got your project open and running in your browser. And we'll take a break here. We'll come back at 12. We're going to need to go through first this process in the Google Developer Console. And then we'll need to go through this part of the process within Visual Studio to get this running. And then once we have that running, you guys can take a stab at the Microsoft login. Okay, let's take a 10-minute break here.